The Wireless Weather Station project features two individual units, one outdoor, one indoor. The outdoor station records temperature and humidity data with a DHT-22 sensor and sends it wirelessly via RF to the indoor station. The indoor station receives and displays the data on two 4-digit 7-segment displays. The user can press the three latching push buttons to see the current temperature and humidity, the maximum and minimum recorded humidity, or the maximum and minimum recorded temperature. The outdoor transmitter consists of a custom-designed PCB with an ATmega 328P and supporting components. The DHT-22 sensor's power, ground, and sole data pin are connected to the PCB through headers. The sensor is housed outside of the case, allowing for it to take accurate readings. The RF module's power, ground, and 5 data pins are also connected to the board with headers. Its antenna is fed through a hole in the side of the case. The housing is an IP65 waterproof box. The power jack and switch are inserted through holes in the side of the box, and all of the holes are sealed with silicone to ensure proper waterproofing. A custom-designed and 3D printed mount attaches to the box and provides two screw holes, allowing for the outdoor station to be mounted on a wall outside. The unit is powered by a 5-volt AC to DC adapter. The indoor unit features another custom-designed PCB with an ATmega 328P. The two 4-digit 7-segment displays are controlled with the TPIC 6C595 and SN74HC595 and shift registers. The RF module is housed underneath the case, with its wires connected via headers to the PCB and fed through the side of the case. The case is custom-designed and 3D printed. The latching push buttons are inserted in holes through the side of the case, with their wires fed through the side and inserted into screw terminals. The power switch is configured in the same way, and the DC jack is soldered underneath the case and is accessible on the side, accepting 5-volt input from an AC adapter. The DHT-22 sensor has a thermistor, humistor, and IC beneath its small open-air housing. A thermistor changes its resistance based on the temperature around it, increasing the resistance with a decreasing temperature. A humistor has two electrodes with a substance between them that holds moisture. As the humidity increases, the conductivity between the electrodes does as well, meaning the resistance lowers. The IC takes these analog values and converts them to a digital signal, which is read by the MCU via a unique one-wire protocol. The RF module is equipped with a long-range antenna and 3.3-volt regulator. Its range can be over 1,000 meters. It communicates with the MCU via the SPI protocol. Data sent from the MCU is transmitted via radio frequency over the 2.4 GHz band using the Enhanced Shock Burst protocol. To allow multiple modules to communicate in the same area, each set are assigned a specific frequency spaced 1 MHz apart, meaning the frequency is typically slightly more than 2.4 GHz. The 4-digit 7-segment displays each feature 4 individual digits. The 8 segments on each digit, including the decimal point, are internally connected, but each digit has its own common anode pin. This means that the 4 digits cannot display different numbers at the exact same time. To get around this, POV is used. The TPIC controls the cathode segments, giving glows to the segments that must illuminate to display a specific number. The SN74 controls the common anode pins, giving each digit a high when its cathode pins are being set by the TPIC. Each digit is cycled through extremely quickly, with only one being on at a time, but it appears as if they are all on due to the speed.